everyone. In our last lesson, we were looking at similar figures, and we were determining whether or not the two figures were similar based on the rate of change between the two. Was it equivalent in the change? So like by the same multiplier. We know that similar figures have the same shape, and they come from either a dilation or a rigid motion. But how do you compare, or how do you find what the value is when they have a perimeter and when they have an area? So today we're going to be looking at two figures that are similar and finding what the value is for the perimeter and then what the value is for the area based on the similar figure. So let's start with perimeters. The most important thing to know is that the value of a perimeter is equal to the side lengths, the proportion that's formed from the side lengths. So the value of a perimeter is equal to the value of the ratio. So we're making ratios, we're making proportions of the value of the ratio of the corresponding sides. That's sponding. There we go. Sides. All right, so we're going to look at value of a perimeter. We're going to be looking at making a ratio and looking at the corresponding sides. So we can find the value of a perimeter by finding the value of the sides. So let's start with two shapes. The first shape we're going to start with is a rectangle and a rectangle. So example A, we're going to compare two rectangles. So we have rectangle A, and rectangle A has one side length of 4. Then we have rectangle B, and these two rectangles are said to be similar, meaning that one is maybe a dilation of the other, but their ratio, or to get from one to the other side lengths, would be the same. So these are two similar figures. One is just a dilation of the other. So our first step we want to do is make a ratio. So we're going to make a ratio. And right now we're going to make a ratio of height, right? So we're going to compare the height of the orange one which is 4, over the height of the blue one. And that is over 6. So far we've made a ratio. Now we're going to find the value of the perimeter by simplifying. So once we simplify this, 4 over 6 is equal to, we can use the same divisor, right? 2 goes into both of these, so if I divide by 2 and divide by 2, I get 2 over 3. So the value of the perimeter that's equal to the value of each side is 2 over 3. So that's going to equal the value of perimeter. So you're just making equivalent ratios, making proportions using the same multiplier or divisor. Okay, let's do one more example of this, and then we're going to go on to area and then I'll give you your triads. So that's it. That's all you're looking for, is that little fraction right there to find the value of it. Okay, this one we're going to start out with trapezoids. Okay, so we have two trapezoids. They're very similar in their shape. So there's one trapezoid. On the bottom here is, the base is 21. And then we have another trapezoid. And the base is 15. So these two are similar. Pretend this one looks like that one. Sorry, my shape drawings are not the best. Again, the first thing we want to do is make a ratio. Well, the two things that we can compare in this one are the bases. So we're going to compare the bases of 21 over 15. Okay, so we're going to compare this one to this one. And our job now is to find, what can we divide by? Well, they both have 3, right? 3 can go into 21 and 3 can go into 15. So if we divide the top and the bottom, it remains proportionate. So the value of the perimeter is going to be 7 to 5. This is the value of the perimeter. You're just dividing down. That gives you the equivalent value of one to the other, what the scale factor is on how they're staying similar figures. Okay, now we're going to go on to area. So we want to find the value of the area between similar figures now. And the way that we find the value in similar figures is, it says that when two figures are similar, the value of the ratio of the areas is equal to the square of the ratio. So we're going to be squaring the ratios. Think about length times width, right? When you have a length and a width, that gives you area. It's squared. So the value of the ratio when it's squared gives you the value of the area. So let's go ahead and write that definition out. So when the value of the ratio of their areas is equal to the square value of the corresponding sides. So the value of the area is equal to the square of the value of the sides of the ratio of the sides. So perimeter, we didn't do anything with squares because perimeter is just a walk around, right? So you were finding how they were equivalent or how they were similar. They had the same value. Same thing with area, except because area is the covering of it, we're not walking around anything. We're walking through the whole thing. So the value of the area is equal to the square of the value of the ratio of the sides. So we're going to find the value of the ratio of the two sides and square it. That's what that means in words. So let's look at what we have. So we're going to have two triangles. We have, let's do example. What are we on? Example C. Here's a triangle. And this triangle is similar to that triangle. One is just bigger than the other. So we have a length of 6 here. Whew, that was a good catch. And a length of 10 there. So we're going to find the value of the ratio. Well, the value of the ratio between 6 and, or we're comparing the side and the side. So we're comparing 6 to 10. Now to find the value of the area, we're going to reduce this. We can reduce it by 2. Divide by 2 over 2. That's going to give us 3 over 5. So here's our value of the ratio, just like we did on the front. But now we're going to square this. So step 1, find the value of the ratio. So simplify it. And then now we're going to square it. So we're going to take 3 over 5. And remember to put it in those parentheses like we did before so that you're squaring both the top and the bottom. And the value of the area then is 3 times 3, which is 9, and 5 times 5, which is 25. So you get 9 over 25. That is the value of the area. So essentially you're doing the same thing, except once you get it simplified, then you just have to square it. Okay, let's do another example, and then I'm going to give you some try-its. All right, example D. And this one gives us, a parallelogram. All right, we've got a parallelogram here. There's one parallelogram. This one has a base of 9. And then we have another parallelogram that's even smaller. And this parallelogram has a base of 6. So remember, our first step is to find the value of the ratio. So the value of the ratio is 9 over 6. We're then going to simplify it down. So we can divide by 3 over 3. That's proportionate. So that gives us 3 over 2. And now we're going to take 3 over 2 and we're going to square this. And that gives us 3 times 3 is 9. So we're back to 9. And 2 times 2 is 4. So the value of the area is 9 over 4. All right, it is your turn now for a try-it. We're going to do 2 try-its. The first one, I want you to find the value of the perimeter. So the value of the perimeter, you have one figure. It is, let's see here. So try-it number 1. You have a rectangle. And the height of the rectangle is, what does it say? Figure A is 9 feet. And then you have another one, and the height of this one is similar to it, is 15. Okay, find the value of the perimeter. And then on example 2, or try it number 2, you are going to have the area of a triangle. So you have triangle P and the base measures 8, and then you have triangle Q and the base measures 7. So we have triangle P and the base of this, what did I say, was 8. And then you have another one and it's 7. You're going to find the value of the area. And this one, value of perimeter. All right, go ahead and hit pause right now so you don't hear me solving these. And then when you are ready, you can come on back and hit play and check your level of understanding. All right, so I'm going to make my first ratio here, and it is 9 over 15. I'm just going to divide the top and the bottom. I know 3 goes into both of these, so that gives me 3 over 5. So the value of my perimeter is 3 over 5. How did you do on that one? Now we're going to check this one, the value of the area. Same process, and then I have to square it. So I'm comparing the two. It's 8 over 7. 8 over 7, that does not have a divisor, right? Oh, there you go. It doesn't have anything that can go into both of those. It is simplified. So now what we're going to do is we're going to take 8 over 7 and we're going to square it. That was a little bit tricky, huh? So 8 times 8 gives us 64, and 7 times 7 is 49. So we get 64 over 49. That is the value of the area. All right, go ahead and rate your level of understanding out to the side. Where are you at? Answer your essential question. What do you have to do in order to find the value of the area and perimeter of similar figures? Remember, these are similar figures. And then when you're done, you can come on back to the Google Meet and ask for help, or you can go and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.